Is your data safe? I mean, sure, your disks are in some sort of RAID configuration such that even if a disk dies, your data doesn't go away with it. But what if your entire server goes away and takes all of your disks with it? Is your data still safe? Hello friends, Mircea here. Let's get one thing straight. RAID is not a backup. Say it with me now. RAID is not a backup. RAID is just redundancy. It keeps you running when a disk dies, sure, but it won't save you from accidental deletes or ransomware or your entire server catching on fire. For that, you need actual backups. And here's the thing. No data exists if it only exists once. At the very bare minimum, you should have 2 copies of your most important data. But ideally, you'd have 3, with at least 2 copies being on different storage mediums and 1 being offsite. This is typically referred to as the 3-2-1 backup rule. 3 copies of your data on 2 different storage mediums with 1 copy offsite. Think of this as the golden rule of not losing all of your data. This right here is my insurance policy. This is a TrueNAS server that I've built specifically for this video. This bad boy is going to live at my parents' place, far enough away that even if my apartment burns down, God forbid, my data doesn't go away with it. Every night, my primary server in my rack back there will replicate snapshots over to this one, so even if disaster strikes, I've got a recent backup. There's still a problem though. Even with 2 TrueNAS servers, well, I don't have 3 copies. There's still a scenario where I could lose everything. What if both locations get hit? What if they both experience hardware failure? Well, that is where Backblaze comes in. For my most critical data, the stuff that I absolutely cannot lose, I'm also sending encrypted backups to an S3 bucket. Call it paranoid, call it overkill, well, I just call it peace of mind. We've got quite a bit to cover in this video, so let's get straight to it. Let's take a quick look at the hardware. For the case, I went with the Johnsbow N4. I picked this case for 2 main reasons. One, it looks nice, and secondly, it fits perfectly in an IKEA Kallax shelf. These were my main decision factors for this case, since this is going to live in my recording studio at my parents' place, so I want it to look nice and out of the way. Inside the system, I have a refurbished Intel Xeon i3 1230V6 on a Supermicro X11 SSL-F motherboard. I picked this combo mainly because it was dirt cheap at 45 euros for the CPU, board and 16 gigs of RAM. But more importantly, it has IPMI for remote management. When this thing is a drive away, being able to access the BIOS remotely and manage the system that way is invaluable. For the boot disk, I went with a 16GB Intel Optane module from AliExpress. I don't need a lot of capacity for TrueNAS itself. What I do need is reliability. Optane drives are plenty fast and incredibly durable, which makes them perfect for a boot device. Since the motherboard doesn't have any native M.2 slots, I'm using a PCIe adapter for this. For storage, I have 5 4TB HGST hard drives. These are actually recycled from my main NAS after my all-SSD upgrade. Rather than let them collect dust, I figured they'd be a perfect use for this backup role. You can see here my backup TrueNAS server. I set up a different theme for this one compared to my main one so that we can easily tell them apart. First up, we have storage. You can see here that I already created a pool on this one and I called it tank. That's what I typically call my main storage pools on my TrueNAS servers. For the layout, since I've got 5 4TB disks to work with, and since this is primarily used for long-term backups, I went with a single RAID Z2 VDEV. Other than the pool, I also set up a dedicated dataset for my backups. Now, technically, I could dump everything in the root of the pool here, but creating a dataset is much cleaner. With the storage sorted, let's go ahead and set up the replication user. For that, I will be using the default TrueNAS admin user that is created during the installation. However, it is not set up quite the way we need it to, so we will have to tweak a few settings. First up, we need to have the full admin privileges set right here. Then, we need to have SSH access enabled. And finally, and most importantly, here for sudo commands, we need to enable all sudo commands and allow sudo commands with no password. This is important because when we configure replication tasks later, we don't want to have them wait around for a password prompt. Finally, before we're done with the system, we need to configure the SSH service. And to do that, we navigate to System and then we go to Services. Here, we need to make sure that the SSH service is running and that it's enabled to start automatically on boot. Finally, we go into the settings here and we need to configure the TrueNAS admin group to be enabled for password login groups, and then allow password authentication is checked. And that should be everything on the remote server. We can now move over to the main one. First thing I need to do is that I need to create a new SSH connection on my primary server so that it can talk to my remote one. So I will add a new SSH connection. For the connection name, I will just call it example since I already have one created. For the setup method, we can keep it to semi-automatic. This works great when both systems are running TrueNAS since they can handle the SSH key exchange automatically. Then, for the TrueNAS URL, I will just paste in the IP address for my remote server, and I will make sure to keep using HTTP instead of HTTPS, and that is because I didn't bother setting up certificates on the remote system. It's all going through a VPN tunnel anyway. For the admin user, we will use the TrueNAS admin user we created earlier, and finally I will put in the admin password for that remote system. Now, I will enable passwordless sudo for ZFS commands, and I will make sure to select here to generate a new private key. This is going to take a few seconds because TrueNAS is generating a new SSH key pair locally, copying it to the remote server, and then finally validating the connection. And you can see here we have the example key SSH key pair generated, and then the example SSH connection. With that done, let's move over to data protection. Here, there are a couple of things I want to take a look at. First, we have periodic snapshots, and secondly, we have replication tasks. We will start off with periodic snapshots because they're actually a prerequisite for replication tasks. You can think of ZFS snapshots as point-in-time captures of your entire file system, and because ZFS is a copy-on-write file system, these snapshots are fairly cheap, both in terms of performance and of space. I can take them as often as I want and without hammering my system. When you take your first snapshot, ZFS marks the current state of all of your data. Then, whenever you take another snapshot, ZFS doesn't just copy everything. That would be inefficient. It only tracks what has changed since the last snapshot. So, for example, if I have a 1 terabyte dataset and then I take a snapshot, modify 10 gigs of files and take another snapshot, that second snapshot only needs to store those 10 gigs of changes. This is why you can have dozens or even hundreds of snapshots without using up massive amounts of space. During a ZFS replication, what we're sending over the wire is not the live data, it's just these frozen in time snapshots. This means that if I run a replication right now, then immediately change some files and then trigger another replication, nothing will happen. The remote server won't see any changes because no new snapshot has been created yet. The replication only sends over snapshots that exist on the source but not on the destination. So, here is how I have my snapshots configured. You can see I have hourly snapshots that are configured to last for 2 days. Then I have daily snapshots configured to last for 2 weeks, weekly snapshots lasting for 2 months, and finally monthly snapshots lasting for 6 months. This gives me really granular recovery points for recent data and then decaying off to longer term checkpoints for older data. These snapshots are what will get replicated to my remote server. And speaking of replication, let's take a look at that next. If we hand over to replication tasks, we can see I have a bunch of them set up here, but let's go ahead and create a new one. Here for the source location, I will choose on this system because I want to push the data out from this system to a different one. And which different one? Well, we want to use the example connection we created earlier. For the source of the data, I will just select, for example, my apps dataset. And for the destination, I will go into the tank pool on the remote system in the backup dataset I created earlier, and I will select the apps folder here. Then, since this dataset has child datasets as well, I will make sure to mark it as recursive. Finally, I will choose no encryption for the SSH transfer security to make things go a bit faster, and you can give this task a name if you want to. Next, we can choose when this task runs, and I want to run it on a schedule, and daily at midnight is reasonable. For the destination snapshot lifetime, Well, here you can choose either same as source to never delete, assuming you have infinite storage perhaps, and then custom if you want your snapshots on the remote system to last for a different amount of time than they do on the source system. In my case, I will keep it to same as source, and then we can save here. Now, here's what makes this setup very efficient. Just like snapshots, replication tasks are also incremental. The first replication task takes a while, sure, because it has to send over all of the data, but after that initial sync, which you can see here already happened for some of my tasks, subsequent replications are much faster because they're only sending over the differential. Even though I'm backing up quite a bit of data here, the nightly transfers are generally in terms of like gigabytes, sometimes even less. To make this initial sync go faster, since the remote system is still here on my network for now, I actually ran all of these replications already to make use of the local network speed, and I don't want to be bottlenecked by the upload and download at my two remote locations. I will now delete the example task we created, and again, since all of these replication tasks you can see already have a state of success, what we can do is that we can log in into my remote system. And if we navigate to the datasets tab, you can see inside the backups dataset, we have the dataset structure that matches what is on my main system. That's one copy of my data on the main server and then a second one on the backup box. What about the third? Well, for that, we have Backblaze. I'm here in my Backblaze console, and what I need to do is that I need to create a new bucket, and I will just call this one YouTube example bucket. The files in the bucket, we can leave them to private because we don't want people to have access to them publicly. For the encryption, we can disable it because we will actually configure encryption on the TrueNAS side, not on the Backblaze side. And finally, for object locking, you can choose whether or not you want to enable this. What this does essentially is that it makes your data immutable. This means that if you delete something locally, it won't get deleted on the remote system as well. But this means that your bucket will grow to a large size eventually, so this may not be desirable. With the bucket created, we want to change the lifecycle settings here. By default, it will keep all versions of the file, and this is kind of like the ZFS snapshots. If you delete something locally, it will appear to be deleted in the bucket, but it will actually hold that file in a revision. So even though you deleted the file, the storage used by your bucket will not decrease. You can make it keep only the last version of the file, so if you delete something locally, it is deleted on the remote bucket as well, or we can just choose to keep the prior, 14 days of data. So if you delete something locally, it will be kept on the bucket for 14 days, and then it will be eventually deleted. I will just choose to keep only the last version of the file. With the bucket created and updated, we need to go into application keys and then create a new application key. We will call this one YouTube example as well. We won't allow it access to all buckets, but rather only to the example bucket I created. It needs read and write access, obviously, and that's about it for this one. Here, it generated the new key ID and application key, which you will want to copy, and then we will take these and create a new backup credential. So we can go back to TrueNAS, credentials, backup credentials, and here, for cloud credentials, we need to create a new one. You will choose your provider from this list. You can see quite a few are supported, but we are using Backblaze B2 here. It will generate a name, or you can set on itself, and here is where you will paste your key ID and application key that was generated here. Now, I already have a credential created, so I'm not gonna bother with this. This is what it should look like. You will have your credential with the provider, the name, key ID, and application key. At this point, you can verify the credential to make sure that the information you pasted is valid. With the credential setup, we can go back to data protection, and now we can take a look at Cloud Sync tasks. Here, again, you can see that I created multiple tasks for various datasets in my system. We can add a new one, and here we will actually have to go into advanced options from the start. We will call this one example. For the credential, we will choose the Backblaze B2 credential we created earlier, and here again, we can choose whether we want to push or we want to pull the data. Similarly to replication, I want to push here, I want the transfer mode to be sync. The difference is that copy will just send all of the data all of the time, whereas sync will just send the data initially and then just send differentials, kind of like snapshots. I will choose the source for the data, and I will choose the apps dataset, for example, here. And then for the destination, I will choose the bucket. Within the bucket, you can also specify folders, and I will specify the apps folder. Here, what you typically would want to do is to use a snapshot for this. And what this means is that it essentially will create a snapshot at the beginning of the task, then it will copy over all of the data from the snapshot, and then it will delete the snapshot. The difference between Cloud Sync tasks and replication tasks is that Cloud Sync tasks will replicate the live data, not the snapshot. So this is a means to ensure that you have consistency in your backups. Since in my case, this is not a root dataset and it has children datasets in it, I can't actually use snapshots for this one, but I'll show you an example later. Then you can choose the schedule at which you want this to run. I will keep it to be daily. And finally, we have a few options here. First, we want to use fast list. And what this does is that it uses fewer transactions in exchange for more RAM. The reason that this is important is that Backblaze charges you for transactions as well as for the storage used in their servers. So the more transactions you use, the larger your bill will be at the end of the month, and this helps reduce that. Finally, I want to enable remote encryption. You see, I trust Backblaze, but not that much. So I want to make sure that the data that I send there is encrypted before it ever touches their disks. So you just need to set an encryption password here, it can be whatever, and then the encryption salt as well. Make sure to keep this saved somewhere safe because you will need them in order to restore the data. If you want to be a real tinfoil hat here, you can even encrypt the file names, though this is experimental and not necessarily recommended. Finally, you can choose for the transfer bandwidth whatever you want. Typically, I run this outside of working hours, so I just leave it on high bandwidth. And finally, we can just save. I won't actually save this one because we already have some created, and I'll show you an example. We can take a look here at my user backup, for example. If I edit this, you can see it's a push to the Backblaze bucket, and then the folder, it's set to sync. For the source, it's my user's dataset, and here I'm actually using a snapshot because this dataset doesn't have any other nested datasets within it. And then I have my remote encryption password and salt. Again, the initial sync here will take a while because it has to send over all of your data, but then any other run besides that will only send over the differentials. So you can see this will be almost instantaneous. To make sure that this is working, what we can do is that we can go into the Backblaze console, go back into Browse Files, navigate to the bucket, and we can see here we have about 500 gigs of data. And if we take a look into users, for example, you can see I have my dataset here. The thing about backups that a lot of people seem to overlook is that if you haven't tested a restore, you don't actually have backups. At best, you have Schrodinger's backups. They both exist and they don't until you try to use them. So let me show you a quick restore test. I'm going to pick a smaller dataset so we don't have to wait around for it, say my apps dataset, and then I'll try to restore it both from my remote server as well as from Backblaze. To do that, let's first go to datasets and then create a target dataset where we want to restore the data. We will call this one apps restore replication. And then we will also create one for apps restore B2. With that done, we can go over to data protection and then let's select the apps replication task here. We can click on show actions and then select restore. What this will do is that it will create a secondary task that we can use, and we'll take a look at that here. We can say test restore, and then for the destination, we will choose the dataset we created earlier, so that will be apps restore replication. You can see here it created a task for us that is not currently enabled, but let's take a look at it before we're trying to run it. We can see the name is test restore like we said earlier, the SSH connection is still our remote TrueNAS system, but the direction now is set to pull instead of push, so we are pulling back the data from the remote system to the current one. Then if we scroll down we can see the task is not enabled, so let's go ahead and enable it. For the source we have the backups apps pull in the remote system and then apps restore replication in the local one. What I need to change here is that I need to use sudo for ZFS commands again, since that's what I also set for my replication task initially, and finally I can save it. With the task saved, we can now go ahead and run it. And it should start pulling the data. We can see it's currently running. While that's going, let's take a look at the cloud task as well. So we have here the backup task for the apps dataset, and we can similarly click here and go on to restore. This will create a new cloud sync task for us, so let's call it B2 restore. For the transfer mode, we can either have copy or sync, similar to what we did when we backed up. I will choose copy because I want to pull all of the data from the bucket locally. And for the destination, I will choose the apps restore B2 we created earlier. Now that the task is created, we can go ahead and enable it and run it. It's been a few minutes, but you can see here that both tasks have finished running successfully. We have the B2 restore task, and finally we have the test restore as well. Let's take a look at the data that was indeed pulled back to make sure that everything is okay. So, if we take a look at my terminal here, you can see that I am in the root of my tank pool on my main system. If we take a look at all of the directories, we can see the original apps dataset and the two restored ones. Now, let's take a look at the contents of the apps dataset. If we now list the contents in the replication buckets as well, we can see that the contents are exactly the same. Now, let's take a look at the size of the directories too. If we take a look at the size of the apps dataset, it's 4.4 gigs. And if we take a look at the size of the datasets that were restored, they are also 4.4 gigs. And there we have it. 3 copies of my data on 2 different storage mediums, with at least one being offsite. My data is safe, my stress levels are lower, and I can finally sleep at night knowing that even if the worst happens, my data will be okay. What is your backup strategy? Are you running something similar, or are you just living dangerously with no backups at all? Drop a comment below and let me know. Maybe you've got some tips that I haven't thought of. If this video was helpful, well, smash that like button, subscribe if you haven't done so already, and ring that notification bell so you don't miss any future homelab projects. Until next time, keep your data safe and happy homelabbing. See ya. If you enjoyed this video and want to take things to the next level, you should definitely check out this one, where I set up a highly available Ceph cluster on top of Proxmox. What we did today gives us redundancy, but if you want true high availability, where your storage can survive entire server failures without missing a beat, well, that's what Ceph is all about. Again, thank you so much for watching, and I'll see you in the next one. Cheers, guys!